Good day, everyone. We are the Group 2 and we will going to tackle about the operation and process of air conditioning system. So first, what is air cycle air conditioning system? It prepares engine bleed air to pressurize the aircraft cabin. The temperature and quantity of the air must be controlled to maintain a comfortable cabin environment at all altitudes on the ground. The air cycle system is often called the air conditioning package or PAC. It is usually located in the lower half of the fuselage or in the tail section of a turbine powered aircraft. So here is the types of air cycle machines. The turbo compressors or bootstrap, the brake turbine, and fan turbine. So once a system has been started by some external power source, the working fluid sustain the process on a self-sustaining basis. Such a system is known as bootstrap system. A gas turbine engine, once started, sustains a bootstrap operation because the turbine continues to drive the compressors that feeds air to the engine. Another bootstrap system used by aircrafts is the bootstrap or air conditioning system, which provides adequate cooling to the cabin and electronic equipment. The bootstrap air conditioning system mainly consists of two units, the cold air unit and a heat exchanger, both of which are mounted in a common shaft. The assembly was supported on the ball bearings until they were placed by air bearings, which provide a lighter solution, requiring less maintenance. The compressor increases the air pressure with a corresponding increase in temperature. The increased temperature is now reduced in the heat exchanger, which is cooled by ram air. This reduction in temperature might lead to formation of water, especially when the aircraft is flying in humid conditions. The water extractor placed at the turbine inlet removes most of the water, thus preventing damage to the turbine blades and spraying water into the cabin and electronic equipment. As the air expands across the turbine, the temperature can drop below 0 degrees, and hence a cold air bypass line is used to vary turbine outlet temperature to get the required temperature for cabin and equipment cooling. So the next reporter will tackle about the brake and fire turbine. Thank you.
So the second air cycle machine ay ang brake turbine. Sa system na to, ang charged air ay directly supplied to the turbine via heat exchanger. Then yung turbine, dinadrive niya yung compressor, which takes in a low pressure ambient air and it expels it through a restriction. So yung pag-expel ng ambient air through a restriction ay nagkakos ng back pressure sa compressor, which puts a brake on the turbine. Kaya tinawag na brake turbine yung system na to. And it provides energy conversion which removes the heat from the charged air. So sa other installations, feed the output from the compressor into the ducting downstream of the heat exchanger to increase the thermal efficiency of the heat exchanger by jet pump action. So yung system na to ay mas magaan kasi isa lang yung heat exchanger niya and the mass flow or weight ratio is better. Pero unless the jet pump is used, hindi siya magagamit para i-cool yung charged air when the aircraft is on the ground. So the next air cycle machine ay ang fan turbine. So ang fan turbine ay refinement ng brake turbine unit, in which instead of a compressor, the turbine is coupled to a fan sufficient capacity to draw the required volume of cooling airflow. So yun nga, imbis na sa compressor yung dinadrive ng turbine, fan yung dinadrive niya sa fan turbine, para hindi dependent sa ram air yung unit sa kanyang operation. Therefore, magagamit ito sa ground. So, ang general design ng unit ay extremely light and compact. Then, the delivery pressure is higher and the turbine speed must be higher to achieve the necessary pressure drop. So, yun yung fan turbine.
Let's now talk about the components involved in the air conditioning system. The first component is the water separator, which is located downstream of the turbine. This removes the excess water which condenses during the cooling process. Next is the humidifier. This is the part that is responsible for increasing the moisture content of the conditioning air to 1 to 2% relative humidity to prevent physical discomfort arising from the low relative humidity. Another component is the mass flow controller. This ensures that a constant mass flow is supplied regardless of the engine RPM by spilling excess air into the atmosphere. Next, we have the temperature control. This regulates desired temperature by mixing hot air with cooled air. It is either achieved by manually positioned valves or automatic controls which compares the pilot selected temperature with the temperature of the mixed air inlet into the cabin. After that is the zone control computer, which monitors and controls the temperatures of the aircraft's zones to avoid large temperature gradient inside the cabin. To support this temperature regulation, the trim air valve component adds hot bleed air supplied by the hot air valves in order to achieve the demanded temperature for each zone.
Now let's talk about recirculation fans. As the name suggests, these fans recirculate air from the cabin back to the cabin by approximately 25%. These systems reduce the requirement for engine bleed air as well as the air conditioning pack's rate of use. Of course, the circulated air needs to be filtered to reduce pollutants and other microorganisms, especially today's coronavirus. Next is the gas per air system, which taps directly from the supply ducts where trim air is utilized. Trim air is the hot engine air that is mixed with the cold air from air conditioning packs. This gas per air system provides air to individually controlled zones in the cabin through gas per outlets like this, or also known as Ponkaluv. In the event of air conditioning failure, this gas per system can utilize circulated air instead. All these systems are monitored and the respective statuses are relayed to the flight crew through the monitoring devices, namely Electronic Centralized Aircraft Monitoring or ECAM for Airbus and Engine Indicating Crew Alert System or ICAS for Boeing aircraft. This monitoring apparatus applies to all aircraft systems in operation. For these topics, there are instruments here to indicate the status of the air circulation as well as the cabin pressurization.
The vapor cycle air conditioning is a process similar to those air conditioners at home and those used on cars. Should note that this system only cools the cabin of the aircraft and it does not pressurize it. The refrigerant used is called tetrafluoroethane or R134A, which is circulated through the tubings and the variety of components inside the closed system. Regardless of the manufacturer, the refrigerant is most often called as freon, which rapidly absorbs the heat energy from all surrounding matter, which is why it is used in this air conditioning. So the purpose of this cycle is to remove the heat from the aircraft cabin. If we look inside, it is composed of 5 components. We have the receiver dryer, the expansion valve, the evaporator, the compressor, and the condenser. Let's talk first on the receiver dryer. The receiver dryer is a component that acts as a reservoir. The freon will go to different series of desiccant in order to remove the water or moisture inside it for it to prevent from the formation of ice or what we call freezing inside the system. The freon will enter this stand tube inside the receiver dryer, then will go out towards the expansion valve. The color indication should be pink because it signifies that it is a high pressure liquid. The receiver dryer is also equipped with filter pads in order to remove the dirt from the freon. So as it goes towards the expansion valve will expand its volume and decreases the pressure, which therefore will turn it to a low pressure liquid, signified by the color blue. So as it goes out towards the expansion valve, it will go to the evaporator. The evaporator is a component to which converts liquid to vapor. The outside air or the ram air will be cooled as it passes through the evaporator because of this low pressure liquid which has low temperature. Then as it goes towards the evaporator, the color will now turn into cyan, which indicates it is now a low pressure vapor. As it goes towards the compressor, the temperature will increase as it reaches its boiling point. The compressor will decrease the volume and increase the temperature and the pressure of the substance, which therefore will make it as a high pressure vapor. The next component is the condenser. The condenser condenses the substance from vapor to liquid, which will turn it into, again, color pink, which signifies the high pressure liquid. Then after the condenser, it will now go again on the receiver dryer component, and the cycle will continuously go on for this system.